We now take up this problem number 36 of your textbook. Now, this problem says that a block of mass 2 kg at 2 meter per second collides with another block of same mass, that means this is also 2 kg and at rest. So, the situation is like this. There is a block of mass moving at a speed of 2 meter per second. And collides with another block of same mass, 2 kg, but at rest, U2. Find, now, what is the problem? What is the question? Find the maximum possible loss of kinetic energy. Now, remember, maximum possible loss of kinetic energy occurs when the collision is completely, totally inelastic. That means after collision, they join together. So you may write here maximum loss of G occurs when the collision is or perfectly means these two join together. So their mass will be now 4 kg to 4 kg, and the two together moves with a velocity, say velocity v1. Then what do you get from the theory of conservation of momentum? So from conservation of momentum, we get mass 2 multiplied by its velocity 2 plus its mass is 2 multiplied by velocity 0 is equal to mass is 4 multiplied by velocity v1. So 4 equal to 4 v1. From here we get v1 is equal to 1 meter second. Then find the maximum possible loss of kinetic. So what is the loss of kinetic energy? So loss of kinetic energy is loss of kinetic energy is equal to what is the initial kinetic energy? For mass m1, it is half into m, half m, v square, v was 2, so it will be 4. Half. The second body was static, so its kinetic energy was equal to 0, minus what is the kinetic energy of final kinetic energy? It is half, total mass is 4 into its velocity is 1, so 1 square. This is equal to 2 gets cancelled. This is equal to 4 minus, here we are left with 2 minus 2 equal to, so this is one answer. Huge. This is the second question number B. Question number B. is if the actual loss of kinetic energy is half of that maximum. So actual loss of kinetic energy is equal to half of that maximum, half of that 2 is equal to 1 joule. That case, find the coefficient of restitution. So in that case, what is the coefficient of restitution? That is what we have to find. Now, in this case, of course, the collision is neither fully elastic nor fully inelastic, right? So in this case, the case is actually like this. This is the first body. We write the case once again. This is 2 kg and velocity is 2 meter per second. And this is moving. And the second body is 2 kg and its velocity u2 is equal to 0. And after collision is the first body, which is 2 kg body. Let's say its velocity is v1, and this will be moving with a velocity v1. There is another 2 kg body, which is moving with a velocity so v2. Second condition is like this. In this case, it is said that the loss of kinetic energy is equal to 1 joule. So let us calculate the loss of kinetic energy, right? So in this case, the initial kinetic energy, we write kinetic energy initial is equal to, again, half m is 2, its velocity was 2, so 2 square, and the second body was at 0, static, so initial kinetic energy is equal to, right? So now we find the final kinetic energy. Kinetic energy final. Final kinetic energy is equal to half m is 2 and v1 square plus half m is 2 into final kinetic energy is v1 square plus v2. So what is the loss of kinetic energy? So loss of kinetic energy, initial kinetic energy is 4 joule minus v1 square plus minus v2 square. So it becomes v1 square minus v2 square. This is given as 1 by the problem. This is 1 joule by the problem. So the problem says that the actual loss of kinetic energy is half of the maximum that could have happened. That is what it says. Right? So from here we get, oh, so v1 square plus v2 square is equal to 3. So, right? square plus V1 square is equal to 3. Now V2 square by V1 square is actually V plus V1 whole square plus V minus V1 whole square divided by 2. Because V1 square plus V2 square is this. This is the left hand side. This is given as 3. Given as 3. Let us stop here. Let us consider this is equation 1. Now, let us find out the values of V2 plus V1 whole square and V2 minus V1 whole square. If you can find out these values, then the problem gets solved. So now, once again, from, as we said, conservation of momentum here, here also we write from conservation of momentum theory. Yes, here, so momentum of the first body before collision was 2 multiplied by 2 plus second body was 2 multiplied by 0 equal to 2, 1 plus 2. So from here, we easily get the values of V plus V1 is equal to one value which we need, plus V1 is obtained. Now let us find out V2 minus V1. Also know that minus 1, that means the speed of, relative speed of separation divided by U1 minus U2, that is relative speed of approach, is equal to coefficient of restitution E. Right? From here, we know the values of U1 and E. We get, from here we get V2 minus V1 is equal to E multiplied by U1 minus U2. 1 minus U2 is E multiplied by 2 minus 0 equal to 2E. So we got the value of V2 minus V. So V2 plus V1 we got, V2 minus V1 also we have got here. Minus V1 is 2E. Now we simply go to equation 1 from 1 x plus V1 whole square. V2 plus V1 is 2. So 2 square plus V2 minus V1 is 2E whole square whole divided by 2, 3. From here we get 4 plus 4E square. From here we get 2. That is equal to half And from here, we get the second answer, and this was the first answer. So this was problem number 36. Now, we shall now take the next problem. We shall now take up the next problem in our next class.